All right, guys, so we are continuing on our 4 or 5 notes, and we are on to quotient of powers today. Who can raise their hand and tell me what quotient means? What does it mean when we say quotient? And everybody should know this. You guys learned about what a quotient is at least in 5th grade. What does the word quotient mean? It's a division problem, right? Quotient is the answer to a division problem. So go ahead and decode quotient of powers for me. I'd probably do quotient of powers. Quotient of powers. And we're going to practice saying that together. So our first and only vocabulary today is quotient of powers. What's the word, class? Quotient of powers. So quotient, we've already talked, is the answer to a division problem. So let's say I had 2 to the 5th power divided by 2 to the 3rd power. So go ahead and write 2 to the 5th power divided by 2 to the 3rd power. Now, we're going to kind of draw this out to show an example of exactly what this means. If I'm taking 2 and raising it to the 5th power, that means I have to multiply 2 by itself 5 times. So I'm going to do 2 times 2 times 2 times 2 times 2. And then in my denominator, if I have 2 to the 3rd power, how many 2's am I going to write? 3. Sorry, I had to yawn really badly. All right. What is 2 divided by 2? Not a trick question. It's easy. What's 2 divided by 2? 1. Go and write a 1 there. Those cancel. What's 2 divided by 2? What's 2 divided by 2? So do you see how those sets of 2's can all cancel? Because they're all just 1, all right? So what are we left with? 2 times 2, right? So we would write that as 2 squared, or 2 to the 2nd power. Now, are you going to want to have to write out all those 2's every single time? No. So who thinks they could raise their hand and give me the rule for quotient of powers? The first rule is they have to have the same base. So this only works if their base is the same. But who thinks they could add? What's the second part of the rule? Take a look at what we started with. Take a look at the answer. Very good. You subtract the exponents. So I'm going to go and write subtract exponents. So we do 5 minus 3, and we get 2. Now, here's something you should also write down where it says subtract exponents. Underneath that, go ahead and write in parentheses numerator minus denominator. You have to subtract in a very specific order. You have to take the numerator's exponent and subtract the denominator's exponent from it. So let's do that one more time. If I have x to the 6th power, how many x's do I write? Yep. I'm just going to show it to you one more time. Sometimes it takes a couple examples for the entire class to get it, so I want to do it a couple times. And if I have x to the 4th power, how many x's do I write? And then let's go ahead and cancel. So cancel anything that's in both places. There are 2 left over. Very good. So how can we write those 2 x's? X squared. Yep, x to the 2nd power. And if you were to use that shortcut that we talked about, you have to subtract the numerator minus denominator. 6 minus 4 gives me 2. So in this algebraic example right here, we have a to the mth power being divided by a to the nth power. We're going to keep the a, and we're going to subtract the numerator m minus the denominator n. So let's go down to example 3. 6 to the 9th power divided by 6 to the 5th power. I don't want to have to write out 9 6s and then 5 more 6s. Very good. So I'm going to go ahead and keep the 6. So you keep the base. That's a kicker right there. You got to keep the base. And we subtract our numerator, 9, minus our denominator, 5. And 9 minus 5 gives you 6 to the 4th power. Yes, sir. Go ahead. That is an amazing question. I'm going to give you a pirate ticket for that. Love that question. Come on up and grab it. We will talk about that in just 1 minute. I want everybody to do this one first. It's an awesome, awesome question. Everybody give this one a shot. And who can raise their hand and tell me what you get for an answer here? S to the 15th power divided by S to the 4th. We get S to the 11th power is how you would read that. Very good. 15 minus 4 is 11. Now, the question that was just asked is a really, really great question. And I'm going to draw this up. We actually talked about this a lot in 8th grade, but because the question was asked, I want to go over it right now. So do you guys have some free space right here? Go ahead and draw a box. We're going to add one more example. And I want you to write x to the 3rd power divided by x to the 7th power. And we're going to draw this out so we can see what would happen. So the question was, what if the denominator has more x's in it than the numerator does? So in my numerator, if I have x cubed, that just means x times x times x. So go ahead and write x times x times x. In my denominator, if I have x to the 7th power, how many x's are you going to write? 7. Now, let's go ahead and cancel some x's. So we cancel these x's, cancel these x's, and cancel these x's. Where are you noticing the x's are left now? In the denominator. Because we had more in the denominator. How many are left in the denominator? 4. So we're going to put x to the 4th power in our denominator. Because there are 4 x's left in the denominator. Now, in my numerator, it kind of looks like there's nothing left, right? We canceled all those x's. It appears that they've all disappeared. Technically, this initially said 1 times x times x times x. There's always this pesky 1. It's invisible math being multiplied out front. So we just simply have a 1 left in the numerator. So your final answer would be 1 divided by x to the 4th power. Does that answer your question? No. There's always a 1. No matter what you've got, there's always a 1 being multiplied by it in math. So since all the x's disappeared, the 1 was the only thing remaining. Like if you have the number 5, technically that says 1 times 5 is 5. It means the same thing. If the smaller number's in the numerator, you'll be left with a 1. Yep. All right, let's flip to the next page. I'm going to start up a second video because I'm going to run out of time.